Hello everybody, my name is Nicholas and today I will present our work ClusterMine, a label-free visual out-of-distribution detection via concept mining, along with my collaborators from the Heinrich Heine University of Düsseldorf. We're interested in the task of out-of-distribution detection, or OOD in short, which aims at identifying whether a given test sample is drawn from the in-distribution denoted as ID, the training set, or a semantically sifted distribution, such as the foggy day for self-driving car as shown in the image on the right. Here, the self-driving system urges the driver to take control of the vehicle as it identifies an unseen case. Mathematically, at test time, we need to be able to decide whether a given test sample X belongs to the in-distribution or not, decided upon the out-of-distribution score S of X, where Xi is the threshold upon which we make this binary decision. Usually, the ROC score is used to quantify performance because it's a threshold-independent performance estimate. In our work, we adopt ImageNet as the primary large-scale visual benchmark and use various out-of-distribution datasets to measure the performance. So mean performance corresponds to averaging across all those different out-of-distribution datasets that are picked from the literature. We also assume access to a vision language model such as CLIP, which is trained with multimodal contrastive learning, and we assume that no labeled in-distribution samples are available. Previous works further assumes that in-distribution class names are available, and using those in-distribution label names, one can perform zero-shot inference, where for all in-distribution text names, we compute their text representation and then find the maximum softmax probability of image text similarities, which we denote as MCM in our baselines in our work. We aim to do something different where we assume that in-distribution names are not available, and thus we are trying to mine them based on a large-scale text corpus Y here, as shown on the right, where the corpus, we assume that it contains some of the in-distribution related concepts, as shown with the green blobs. So our task becomes mining these in-distribution related concepts, which we denote as positives. And we assume that all the non-positive concepts that are not mined correspond to negatives. Further mining and selecting upon those negative concepts did not show any performance improvement. So to mine these in-distribution related concepts, we present a new method called ClusterMine, where in the first step, we perform feature-based clustering using k-means or an alternate algorithm called TB. After clustering the in-distribution samples, we go in each individual cluster C and find all the samples from the in-distribution that correspond to this particular cluster. Then we use zero-shot inference using CLIP, using the whole corpus to derive a label for each pseudo-label for each individual sample. Our purpose here is to derive a label for the whole cluster, which we do by applying majority voting, meaning the class names that correspond to the most frequently appearing class name will be assigned in the whole cluster. In this way, albatross in this example will be assigned in the set of in-distribution label names, and other concepts will be rejected, resulting in fewer false positive concepts, as shown here with the penguin in the red. At test time, we incorporate the negative concepts as shown with this existing score, where the nominator shows the positive image text similarities, weighted using also in the denominator the negative image text similarities. Importantly, our method has the hyperparameter to decide which is the number of clusters, where we show that a rough overestimation of the semantic categories is insufficient. It doesn't show any sensitivity in terms of the mean ROC across 6 out-of-distribution datasets. Additionally, we quantify the performance of the mined label name compared to the ground truth, where on the left we calculate the top one text-to-text similarity of the mined concepts with the ground truths and find significantly high values for most mined concepts. While on the second visualization on the right, we find the shortest path that corresponds to the minimum amount of number of hops one needs to do in the WordNet tree. This, of course, assumes that we use the WordNet corpus, which contains roughly 70,000 concepts. Importantly, ClusterMine, our method, is the first method that achieves competitive state-of-the-art performance without access to in-distribution label names, unlike the previous works indicated by the first 3 rows. Here we report the arrow performance as a performance metric. Additionally, we show some small performance deterioration, unlike previous methods that are more susceptible to in-distribution shifts, so covariate shifts, where the different in-distributions are shown during evaluation on the x-axis. And we find that our method is quite robust to changing in-distributions. Finally, we report very consistent improvements in terms of ROC across different clip weights, where our method is indicated with the blue circle. Thank you so much.